For this video, we will be using the Accelerated 7, Unit 2, Scale Drawings, Similarity and Slope, and this video will address scale drawings and how they are connected to dilations. When we're scaling, we are enlarging or shrinking, increasing or decreasing a shape by a given scale factor. And the scale factor is always going to be multiplication. We're multiplying by a number to either enlarge or shrink, increase or decrease. So I like to think of this as like enlarging a photo that you might have on your phone. And I have an example of like a very small image or rectangle, and we're going to enlarge that by a scale factor. So the scale factor can be any number. I'm going to use a scale factor of 2, and I'm going to use SF just as abbreviation, scale factor of 2. Okay, so here's my little shape, and I want to enlarge the length and the width. It's very important that students do both by the same scale factor. So if I have 3 times 2, that is 6, and if I have 2 times 2, that is 4. So my scale copy of the original is going to be 6 by 4. So I'm going to do it right next to it just so we can kind of see the height. So here's 1, 2, 3, 4, 5, 6, and then 4 across. 1, 2, 3, 4. Okay, so this is going to be my new rectangle, and I'm just going to freehand draw it. All right, so I've just created a scale copy of my original rectangle using a scale factor of 2. I've multiplied both the length and the width by 2. So my new dimensions are 6 by 4. So I would say that this is a copy. This is a copy of the original. So if this is the original, using a scale factor of 2. Now your scale factor, like I said, can be any number. So let's do a scale factor. Let's skip a couple and do a scale factor of 5. Okay, so a scale factor of 5 means I'm going to take the original. Again, this one is the original, so I might even code it as the original so I don't forget. And this time I want to use a scale factor of 5. So I'm taking my original image and I'm going to do 3 times 5, which is 15, and 2 times 5, which is 10. So my scale factor of 5 copy, so it would have a height or length of 15 and a width of 10. So I'm going to go ahead and count that out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you can see it's pretty big. And then I'm going across 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to use a ruler to connect these just to make it nice and straight. Okay, so there's my height or my length, width. Again, those are interchangeable terms. I like to refer to this as base and height. All right, and I'm going to do the same thing on the other side, just being careful to make sure I line it up. Accuracy is very important with this unit, so encourage your students to be using a ruler. Okay, so I have my new dimensions, 15 by 10. Now, these are called scale copies. I've enlarged my original shape using a scale factor of 2 and a scale factor of 10. What if I want it to decrease or shrink? These would be increase, okay, using the scale factor of 2, a scale factor of 5. Now, this would be what happens if I want to shrink a shape. So we're going to do an 8 by 1, 2, 3, 4, 5, 6. We'll do 8 by 6. Okay. So what happens if I want to take this original and I want to decrease it? Anytime we're decreasing, we're using a fraction, or the number we're multiplying by will be a fraction. If we're increasing, the number is going to be a number greater than 1. So it could be 1.5, it could be 2, 2.5. It can be a number that has a decimal, but it's going to be greater than 1. So when we're increasing, that the scale factor will always be greater than 1. Okay. Now, when we're decreasing, the number is always going to be less than 1. or a fraction, less than 1. Okay, so I want to shrink this by using a scale factor of 1/2. So if I want to decrease, I would have a scale factor of a fraction, which would be half. So I'm going to take the length and the width, and we're going to cut it in half. Now, scaling is multiplying. The operation that we're doing is multiplying. So we are looking at this as 8 times 1/2, and I'm just going to kind of write 8 times 1/2, which is the same thing as dividing by 2. So if I'm cutting something in half, I am dividing by 2. However, we like to keep the scale factor in terms of multiplying. So I'm multiplying by 1/2. 8 times 1/2 is 4. So I'm going to just come over here and do 1, 2, 3, 4. Okay, so there's my new height. And then I'm going to take my scale factor of half and multiply that by 6. So 6 times 1/2 is the same thing as 6 divided by 2. However, we're keeping the form of multiplying. Scale factor of 1/2, 6 times 1/2. 6 cut in half is 3. And I've just made my copy. Okay, so this would be using a scale factor of 1/2. I have my original, and I shrunk or decreased it using a scale factor of 1/2. The few things that we highlight with the students is that when we increase, we're using a scale factor greater than 1, and when we're decreasing, we're using a scale factor less than 1. If we have a scale factor of 1, nothing is changing, right? So if I had my original and my scale factor was 1, 3 times 1 is 3 and 2 times 1 is 2, so nothing changes. The other thing we highlight with students is when we're scaling, the angles do not change. The angles do not change. We're not changing anything about the shape's angles. The only thing we're changing is the lengths and the widths, or the sides, the lengths of the sides. If it's like a triangle, and all 3 sides would be increasing by that scale factor. So if the original has right angles, all of the scale copies will also have right angles. The angles do not change. Now, how does that connect with dilations? When you're dilating, you're doing the same thing pretty much as scaling, but we're using a point or a location to dilate from. So if I want to take this triangle QRS and I want to dilate it, and again, dilating is the same thing. We're enlarging or shrinking. It's very similar to scaling. It's like kind of the same concept of scaling. We're either increasing or decrease by a number, by a scale factor. Now, in this particular example, this one is actually in our lesson, and I'll show this in just a second. But how would we go about doing this? How would the students go about doing this? So the first thing they have to do is see, well, if my center is T, that means my points are coming from T. So I would take my pencil and just kind of connect just so I can see my lines of dilation. So that's the first thing we would tell students is just look at where these lines are going. And I notice that to get from T to Q, I'm going over 1, 2, 3, and up 1. Okay, so the location from T to Q is over 1, 2, 3, and up 1. So if I want to use a scale factor of 2 and I want to enlarge this shape, I need to take this point and go over 1, 2, 3, 4, 5, 6, and up 2. If the distance from T to Q is over 3 and up 1, if I'm doubling that, I need to go over 6 and up 2. Okay, so this is going to be my copy of Q. And I'm just going to label it. And then I'm going to go and do the same thing for R. R, the distance from T to R is I have to go over 1, 2, 3, 4, and down 1. So I just count my boxes 1, 2, 3, 4, and down 1. So I'm going to copy that. I'm going to go over 1, 2, 3, 4, but I'm doubling 5, 6, 7, 8, and down 2. And this is where my new R will go, R copy. Okay. Last but not least, I have my S, and my S is down 2 and over 2. So down 2 and over 2. So I'm going to copy that down 1, 2, but keep going. 3, 4. Remember, I'm doubling. Over 1, 2, 3, 4. And that's where my S copy is. This is the cool part. I can connect my shape to see, copy, that this is the same shape. Make sure I get that line straight. Okay, so I've just replicated this original QRS. This is my copy QRS. I might even, put it in the same color so that I can see. Color coding, markers, color pencils, these are all great tools to have with geometry. Now, if I did this correctly, then the lines of dilation will hit and continue. And you can see if I line T up with S and the copy of S, they form this nice straight line. And then I can continue T to R to the copy of R, just kind of line it up, and it makes this nice straight line. And then T to Q to copy of Q, same thing, line it up as nicely as I can, and it makes this nice straight line. So what we have done is we've just created this copy of QRS using a scale factor of 2 with a point of dilation, which is going to be outside of the shape. Now, sometimes we can dilate from the shape, sometimes we can dilate from a point, and when we get into coordinate planes, we'll dilate from locations on a graph. This can get a little tricky, so having a ruler and having graph paper is a really good tool to have. Now, the other thing they can check is they can use the measuring tool, and they can see that from T to Q, the line is about 1.5. So if I look at that, it's about 1.5. Now, if I did this correctly, the line from Q to Q copy should be double that. And you can see that it is. This is 1.5, and from Q to Q copy is 3. Okay, so I have just used my line of dilation, my point T, center, to enlarge this shape using a scale factor of 2. Now, this was taken from, I'll pop back up in here. This was taken from lesson 10, and it's this one right here. So the students have to find this shape with using a scale factor of 2. Now, what happens if we need to use a half? Now, this is a really small shape, so cutting it in half is going to make it really small. If I pull my paper back up and I say, okay, I want to shrink this shape, it is going to be super tiny in here, right? It's going to be really small. If I know I had to go over 3 and up 1, I need to cut that in half. Half of 3 would be 1.5. And then half of 1 would be a half. So right here would be Q copy using a scale factor of a half. It's going to be really tiny because I'm cutting this 1.5 in half. Then I'm having the R, if I go over 1, 2, 3, 4, and I go down 1, half of that would be over 1, 2, and down a half. And you can see it's right on the line of dilation. You can actually see it. And then going down 2 and over 2, cut that in half, down 1 over 1. So here's that little triangle if I scaled it using a scale factor of 1/2. Okay? Graph paper, rulers, very, very helpful for this unit. Scaling and dilations. They are very closely related, and they all revolve around scale factor. The key is making sure that we enlarge all sides of the shape by the same scale factor. And when we do that, we have the same shape, just not the same size. So all of these angles are going to be congruent.